Hello, welcome to 3.2. This is solving systems. Algebraically. Okay, so there are two different ways to do this, and we're going to learn both. The first one is substitution. This is where you want to first isolate a variable, substitute it into the other equation, and then solve for both variables. So let's practice this. These problems are going to be coming from page 146, and we're going to take a look at number 10 first. We have 4x plus 2y is equal to 7, and then we have y is equal to 5x. Now, when it says to isolate a variable, this one's already done for us. Do you see how y is equal to 5x? So what we're going to do is we're going to take this and substitute it into the other equation. Okay? Now, I always show it by circling it. Since y is equal to this, I'm going to put it where I see my y. So, I'm going to have 4x plus 2 times 5x, since y is equal to that. And then I'm going to solve for x. Notice in this step right here, you only have one variable. So here, if I have 4x plus 10x is equal to 7, then I'm going to have 14x is equal to 7. Dividing both sides by the 14, I'm going to have x is equal to 1/2. So that means that x is 1/2. If I want to solve for y, I'm going to take and circle this, go from circle to circle, and put in that value for x. So y is equal to 5 times 1/2, so y is 5/2. Now, remember, this is the coordinate, and this shows where these two lines would intersect. And I want you to think about this. This is a more accurate way than actually graphing. So it's good to know how to do this algebraically. All right, let's do this one more time. Let's take a problem like number 14. If I have x plus 3y is equal to 7, and then I have 2x minus 4y is equal to 24. So, with this one, since I don't have a variable by itself, I want to look and target a variable. You always want to try to target a variable with a coefficient of 1. In other words, there's no number in front of it. So here, I would look at this x. So what I'm going to do is I'm going to get the x by itself. I'm going to subtract the 3y from both sides. So x is equal to 7 minus 3y. Here the order doesn't matter. I'm not trying to put this in slope-intercept form. Now I have x is equal to something, so I'm going to take and circle that and move it over where I see my x. Circling it and pointing to where this x goes is a good thing. So I'm going to say 2 times 7 minus 3y minus 4y is equal to 24. So next I'm going to say 14 minus 6y minus 4y is 24. And I'm going to solve for y. So first I'm going to gather up these terms. Remember, minus 6 minus 4 is minus 10y. There's the 14. And now I'm going to subtract the 14 to get negative 10y is equal to 10. So what's y? Well, it's negative 1. All right, so now I found y. Y is negative 1. Remember, I need an x and a y part. So I'm going to take this, circle it, and go from circle to circle. So now I'm going to say x is equal to 7 minus 3 times negative 1. So that's going to be 7 minus 3, which is 4. So here, I'm going to have the coordinate 4 and negative 1. Now the good thing about these problems is you can easily check them, okay? This needs to work for both equations because it's on both lines. So if I wanted to, I could check, and it's always best to check with the equation that you did not use last. In other words, I don't want to look at this one, I want to look at this one. So I'm going to write this down. I'm going to say 2x minus 4y is equal to 24. Then I'm going to take and replace my x and my y where they go. So I'm going to say 2 times 4 minus 4 times negative 1 is equal to 24. And we can see that something is wrong because 8 plus 4 is not equal to 24. So let's see where we made a mistake. That's 14 minus 6y minus 4y. Okay. 14 minus 10y. Subtracting. But y is negative 1. 7 minus, oh, there it is, right there, plus. Okay, so now this is 10, isn't it? So my coordinate is not 4, 1, it's 10, negative 1. And you can see why checking your answer is a good thing. So, if I say 2 times 10 for my x, minus 4 times negative 1, I've got 24. So 20 plus 4 is 24. And again, you can see why checking your answer is a good thing, because remember, in math, it's either right or wrong, okay? So, since we made a mistake, let's practice one more. Let's say we're going to take a look at number 18. All right, so if I have r plus s is equal to negative 12, and then I have 4r minus 6s is equal to 12. All right, first, I want to target a variable. So I'm looking for coefficients of 1. I see r and s. It doesn't matter which one you do, so I'm going to go ahead and subtract the s. So I'm going to say r is equal to negative 12 minus s. Remember, that's an s, not a 5. So now I'm going to take and circle this. R is equal to this, so I'm going to put it where I see my R. I'm going to say 4 times negative 12 minus s minus 6s is equal to 12. So 4 times negative 12 is negative 48. 4 times negative s is negative 4s. Minus 6s is equal to 12. So I'm going to gather up these two. I'm going to have negative 48 minus 10s is equal to 12. I'm going to add the 48 since it's negative. I'm going to have negative 10s is equal to 60. So s is equal to negative 6. All right, so now, circle to circle. So r is going to be negative 12 minus negative 6. Negative 12 plus 6 is negative 6. All right, so now when you think of this as a coordinate, go in alphabetical order. So if I have r and s, let's see if this works. Remember, don't use the one that you just used, because that way you should always get the right answer. Use the other one. So if I check this, with this side, 4r minus 6s is equal to 12. Let's see if I got this one right. So 4 times negative 6 minus 6 times negative 6 is equal to 12. So is negative 24 plus 36 equal to 12? Yes. So this one, I know without a doubt, is correct. Okay, so that takes care of substitution, although I would like for you to try number 16. So if I have t is equal to 2r plus 3, and then I have 5r minus 4t is equal to 6, I want you to pause the video, and then I want you to work this out. This one has a variable by itself, so remember, to start this problem, we're going to take and move this right over here. So pause the video, try it, find a solution for both r and t, and then we'll resume. All right, let's see if you've got it. Did you get negative 6 and negative 9? Because here, that would be the solution. I got r is equal to negative 6 by taking and distributing this, negative 8r minus 12, combining my like terms, 5 minus 8 is negative 3, adding the 12 to both sides, negative 3r is equal to 18 means r is equal to negative 6. Remember, from here we go circle to circle. So 2 times negative 6 plus 3 is negative 12 plus 3, which is 9. And then I did check with this equation. Okay, hope you got it. All right, so the next thing we're going to do is elimination. With elimination, I want you to remember you want to eliminate one or the other variable. So here, we're going to start with 22, and I want you to see what we're looking for. All right, we are looking for variables with the same coefficients but opposite signs. So here, do you notice that I have a plus y and a minus y? If I go to add down, then what's going to happen is they would cancel, which is exactly what we want. So here, x plus x is 2x, the y's are canceled, and this is equal to 14. So x would be 7. Now remember, I have to solve for y. So I'm going to look at the top equation to solve for y. If x plus y is equal to 12, and x is 7, then what does that make y? Well, if I subtract 7 from both sides, y is equal to 5. All right, so now we have the coordinate 7 and 5, and I want to check with the bottom. So use the bottom one to check. And that way you'll know it works for both. So if I say x minus y is equal to 2, remember this is your x, this is your y, and it works. So I think you're going to like elimination. Let's try this one more time. Let's take a look at a problem like 28. So for 28, I have 3x plus 2y is equal to 6. 3x plus 3 is equal to y. And I want you to notice that I have the same coefficients here, the 3's, but one of them is not negative, and I need for that to happen. So what I'm going to do is I'm going to multiply either the top or the bottom. In this case, I'm going to multiply the entire bottom one by a negative 1. So as I do this, I'm just going to rewrite the top, and the bottom, I'm going to just take and change all the signs. That's multiplying by negative 1. I think I forgot my y here. And yes, I did write it down wrong. 28. Oh, I did not write it down wrong. All right. So, is equal to negative y. I need to rearrange this. So let's do that on the next part. Let me go over here. 3x plus 2y is equal to 6. If I were to rearrange these two, I want you to realize that this would be negative 3x plus y is equal to a positive 3. That's adding y to both sides, adding 3 to both sides to rearrange those. Remember, as I take it over an equal sign, I change the signs. So now, we are ready to add down. 3x minus 3x, gone. 2y plus y is 3y. 6 plus 3 is 9, so y is equal to 3. Remember, use the top to find the other variable. So we're going to say 3x plus 2y equals 6. Replace the y with a 3. So 3x plus 6 is equal to 6. What's going to happen here? It's going to be interesting. If I subtract 6 from both sides, 3x is equal to 0. Well, if x is equal to 0, 3 times x is equal to 0, then x has to be 0. So my coordinate then is 0, 3. So let's check this. Remember, I want to check with the bottom. So if I say negative 3 times, well, let's say x plus y is equal to 3. If negative 3 times 0 plus 3 is equal to 3, then I'm good. And I am. Okay? All right. Let's try that again. Now, on 31 through 42, you may have to multiply the top, the bottom, or both to make an elimination happen. And as long as you multiply all the way through, you're going to be fine. So let me give you an example of that. Let's say I've got something like 32. If I have 9a minus 3d is equal to 3, and then I have negative 3a plus d is equal to negative 1. All right, so now I need to decide which variable I'm going to target. So, since I see this has a coefficient of 1, I'm going to target my d's. Now, I need for these to eliminate. Please notice that they have opposite signs here, but I need a 3. So I'm going to multiply the bottom by 3. And let's see what happens here, because I think it's going to be pretty interesting. I'm just going to recopy the top, and then on the bottom we've got negative 9a plus 3d is equal to negative 3. Now wait a minute. Let's take a look. If I add down here, then these will cancel, these will cancel, which means I've got 0 on this side, and this is a 0. So when is 0 equal to 0? Always. Remember this? So we have an infinite number of solutions, and in other words, I have the same line. Okay? That was kind of neat. All right, let's do this again. Let's say I have something like 38. Okay, so 5x minus 2y is equal to negative 19. 2x plus 3y is equal to 0. So now, as I look at these coefficients, I see that these have unlike signs, so I'm going to go ahead and target my y's. All right? Because that will be one less thing I have to worry about is the signs. So here, I'm going to multiply the top by the bottom number, the bottom by the top number. So here I'm going to multiply the top by 3. And when you do this, please remember to multiply the entire thing through. So we're going to say 15x, 3 times 5x. 3 times negative 2y is negative 6y. 3 times negative 19 is negative 7 to 57. Negative. All right. So on the bottom, I'm going to multiply the bottom by the top number. So here we're going to have 4x plus 6y. Notice here those y's are going to cancel. And 2 times 0, well, that's still 0. But remember this back number. If you make a mistake on this, that's probably where it is. So as I add down, I'm going to have 19x is equal to negative 57. So x is equal to negative 3. All right, so now remember, use the top to check. When I say the top, I mean use the top original. So we're going to have 5x minus 2y is equal to negative 19. Throw in the x so that we can solve for y. All right, 5 times negative 3 is negative 15. Minus 2y is negative 19. Add the 15. Since it's negative, I'm going to have negative 2y is equal to negative 4. So y is equal to a positive 2. So here's my coordinate. Negative 3 and 2. We're going to check with the bottom. Always check. It's worth the time to do this. So if I say 2x plus 3y is equal to 0, 2 times negative 3, my x, plus 3 times 2, my y, is that equal to 0? Well, yes, because negative 6 plus 6 is 0. So again, you can feel confident in your answer of negative 3 and 2. And remember, this is where these two lines would intersect. All right? So, we're going to take, and I want you to try one. We're going to take number 42. We're going to step our way through this. If I have 3m plus 4n is equal to negative 13, and 5m plus 6n is equal to negative 19. Now with this, we're going to have to multiply the top and the bottom because my variables are not the same. So how about if I take and target my m's, and that means I'm going to multiply the top by the bottom number and the bottom by the top number, but because they have the same signs, I need to make it a negative 3. So I want you to multiply these two across and see what happens. So on your own, multiply these across. I'm going to pause the video. Okay, did you get this? Did you remember to multiply the back numbers here? All right, so now as I add down, these are going to cancel. I'm going to end up with 2n is equal to negative 8. So n is negative 4. Okay, so now, remember, do the top part of the original to solve for the other variable. Okay? So again, I'm going to pause the video. Let's see if you can find it. Okay? Did you find that m is equal to 1? That's what I have, so let's make sure we check our answers. Remember, you want to check with the bottom original. And we are going in alphabetical order, so we're going to have 1 and negative 4. So again, pause the video, check your answer. Use the bottom equation. Did you get the solution? I hope so. So here, I got 5 minus 24 is negative 19. So next, I want you to try a few problems. I'm going to show them, and we're going to go over them in class. Remember, with these, you can check your answers. I want you to try numbers 1, 2, 3, 4, and 5. So just problems 1 through 5. Okay? Remember to check your answers. That way you will know if the problems are correct. By the way, if you can't read this, if you take a look at your page 145 from the textbook, that's where these problems are coming from. Again, problems 1 through 5, have those done before class so that we can see if you have questions. Okay? Have a great night. Bye.